friends, this is Eli from Mystic Circuits. Today we're going to be showing you how to build the 0 HP Vactrol module. This is able to build one of two modules depending on how you populate a particular component. It can be either a Vactrol low-pass gate or a Vactrol VCA, and we'll go ahead and show you how to choose which one you want to do. I would say before you start, kind of in your head, make the decision as to whether or not you would prefer an LPG or a VCA. And if neither of those terms make a lot of sense to you, or you're not sure exactly which one you want, I would say just stick with the LPG. That's one's pretty popular with people. So there are a couple of different versions of the circuit board, and some of the versions have some errors on them. So I'm going to go ahead and show you how to differentiate that. We're going to open this up. This is our kit. It should have everything we need in it. Take the bag to the side. This is the instruction pamphlet. You can see here, there's a picture of the board. We've labeled the resistor that had a misprint for the value. You can see here, it mentions that the silkscreen is incorrect. So we'll go over that again before building. And then the QR code over here is possibly how you found this video, but it will take you to a more detailed step-by-step instruction book that shows all of the instructions for building this module. We're going to go ahead and put this to the side. Here you can see our passive component sheet. This has the VCA resistor and the LPG capacitor, and we'll show you where to put that later. You're going to have a little active component bag that has the actual Vactrol and LED in it. These probably didn't need static shielding, but I do it just in case. So go ahead and open this bag up, take out the contents, just verify that you have everything there. And now there should be a third bag with all the hardware. We're going to go ahead and empty that out as well. It's a good idea when you start building any of these to just look over all the components and make sure that you have everything. Sometimes a part doesn't make it into the right bag, and if that is the case, then go ahead and contact us and we'll sort you out. So here we have the lid to the module. It will either say low pass gate or VCA, right? And they're on opposite sides. Then there's the bottom to the case. This is the actual circuit board. You should see Vactrol VCA / LPG. Here are two of the short sides to the case, which have the holes in them, and the long sides, which say Mystic Circuits on them. You should see 4 jacks, 4 rubber feet, 4 nuts, and 4 bolts, right? So for now, we're going to go ahead and put all the case stuff to the side and focus on soldering the actual module. I would say that this module, it's not the easiest one that we sell, but it's pretty simple. And so I would say if it's your first time, this wouldn't be the worst build, right? So the only thing that's funky about it is that there are a couple of misprints on the circuit boards, and I just, couldn't be bothered to fix them. I've memorized it. I'm putting it in all the instructions. So we're going to go ahead and with a Sharpie, just make a couple marks here. We're going to cross out this 10K over that's the closest to the mix in order to help us remember that that is the incorrect place. And there's also some modules that came without this white line indicating the direction of the LED. So if you don't see a white line over here above where it says Vactrol, go ahead and add one with your Sharpie right there to help you remember that that's the direction that the cathode goes for your LED. All right. So after that, we're going to go ahead and take the 10K resistor. You should see 1K times 3, 10K times 1, and then 22K at the bottom. So we're going to start with the 10K resistor, right? Take that off our sheet, taking the pieces of paper off of both sides, throw those away. And we're starting with this one because this is the one that's mislabeled on the board. All right, so if you didn't see what I just did, I'll go ahead and undo it. Our resistor starts out in a straight line like this. We're going to take one side and we're going to bend it all the way over into a little U-turn kind of shape. All right, so that it's nice and skinny like that. And then we're going to take it and place it into the board. I usually like, it doesn't matter too much, but I usually like to have the body of the resistor matching up with where there's the white circle on the circuit board. So take the long leg, put it through the white circle, short leg, put it through the other side. All right. And so now our resistor is in the board. If we flip it over, it's possible that the resistor will wiggle itself free or something like that. So what we're going to do is we're going to take our finger, place it against here, right? Push into the board, and then you can split the legs like this. And I realized that didn't get caught on camera very well, so you're going to see me manually focus and unfocus sometimes. So just be patient, please. So finger on top of the resistor, pushing it into the board, and then you can take your legs and kind of push them apart like this, right? And now I think with this design, it's easy enough to just solder all the resistors at once. So we're going to go ahead and populate them, and then I'm going to move those legs around a little bit afterwards just to make sure that no solder gets anywhere it's not supposed to be, right? So now just go ahead and verify that the only resistor that you have in the board is the one next to the mix-in, the one that we marked with the Sharpie, and is in fact the 10K resistor, right? Those are all important to do at this stage of the process, okay? So now I'm going to go ahead and take these other resistors. We're taking them off. Take off the tape. Take off the little bits of paper on the sides. And we're going to do the same thing with each one. We're going to take it by the body and fold over one of the legs so it makes a little U-turn kind of shape. And then on all of the places in the corners that are marked 1K, 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 that's where we put our resistors. So go ahead and put your resistor in through there. Again, I'm putting the body of the resistor in alignment with the white circle. So a long leg goes through the white circle. And then on the other side, these legs are a little bit tangled up. I'm going to go ahead and move this leg out of the way just so we have some room to work. Bend the legs over to help keep the resistor in place while holding the resistor from the top of the board. Next one, bend it over. Place it in the board. Again, long leg into the white circle. And if you're at all unsure about which holes, because there's a lot of holes that are kind of right next to each other in there, whenever you're putting a resistor into its footprint, you'll be able to see that there's like a little white line connecting these two holes. You see that right there? It's hard to get on camera. Right there. Right? That white line indicates that the resistor goes across those two holes. All right? And you can pause after I put this one in and just verify that your resistors are all in the right place before soldering. Should be pretty easy to see. There's these two pins in the middle that are still empty, and then these two pins in the middle that are still empty. There's basically a pair of two in between each resistor, right? So if all of that looks good and you feel confident that this is your 10K resistor, go ahead and flip this over. We're gonna arrange these legs in such a way that makes everything a little bit easier to solder, right? And usually what I like to do is I like to have each leg pointing away from any of the other solder points that are close to the point that we're going to solder in. So that means I'm going to take some of these legs and kind of point them towards the middle of the board, because there's nothing going on in the middle of the board that can accidentally get solder in it, right? We're trying to avoid getting solder into a point that has a point next to it, right? Because if we accidentally get solder into one of these holes, it's not the end of the world, but it is an annoying process to try and get the solder out before we can put the parts back in, right? So if you've never soldered before, I am going to link a video at the bottom where I go over the absolute basics of soldering. I also cover some safety tips, both for heat and chemicals, and some tricks that I've developed along the way. But what we do every time we solder, I feel like Bob Ross saying this, what we do every time we solder is we tin the tip, right? And basically that takes the shiny part of our solder tip. You can see up here, right? It's not super shiny, and a happy little soldering iron wants to be shiny, because the shiny solder is the freshly molten solder. There's no chemicals that have oxidized to the surface, creating a difficulty. Chemistry was not my strong suit in school, but basically you want your iron to look nice and shiny like this instead of brown and black like that. And you know, in my situation, one of my sides is brown. I need to get some tip tinner in order to fix that. I think I have some sitting in a box somewhere, but basically as long as one of your sides is nice and healthy looking like this, you should be good to go. So ideally take the side that's shiny and healthy looking, right? And I've said this a couple times already, but if you haven't watched yet, a lot of people think you just take the tip of your iron and you put it against the leg that you're trying to solder. That's not correct. Being careful not to get your iron on top of any of the adjacent points. What you want to do is you want to put the side of your iron against the leg, because that increases the surface area to heat. You push your solder into the joint and then you let it sit there for a second and lift off, because that allows the solder to sort of smoothly go across the entire joint. And normally I'll flip the thing entirely backwards, but you can actually do it like this on the side and just go towards the tip. If the tip of your iron is not clean, it might be a little harder to do that, but we can also, I'll show you another method for doing this. So I'm just going to get all of the joints that are easy to get, and what I like to do instead of putting my iron into a bunch of awkward positions is I just rotate the entire board so that my hand and my iron is in a nice neutral position the entire time that I'm soldering. Makes it easier to focus on just getting the joint correct, not on trying to balance a whole bunch of things, just looking over these joints. They all look good. Okay, so now that those joints are done, what I'll do is I'll take the legs that are finished, and I'll kind of push them out of the way, and then because those are holding these together, I can move some of the joints around that haven't been soldered, and we can sort of refocus on those, right? So go ahead and hit this one. And then I'll do these two. Okay. So a good way to test and make sure that these joints are done, obviously it's ideal to wait a couple seconds, just because these legs can still be hot because they've been conducting hundreds of degrees of heat. But if you just wiggle the leg around, you can see that this section of the joint right next to the circuit board doesn't want to move, right? If you're wiggling the leg around and you see that little ball of solder on the board moving with you, that indicates that you have a cold joint. You should go back and heat up the solder again until it flows smoothly onto the board. Right, and these ones in the middle, I'm gonna go ahead and I'm not even gonna cut them with this. I'm just gonna grip them with my wire cutter and kind of wiggle them around. You can, if you're gentle enough, you can use the wire cutter as a pair of pliers. Right, there you go. So what we're going to do now is we're going to cut off all the excess leg from our board. And the way you want to do this is to get as close to the joint as you can, right? And then you want to apply only sideways pressure with the wire. What you don't want to do is to grip the wire, right? And then pull away from the board, right? Like in this direction, because that has the potential to break the joints that you just made. You want to focus on trying to do it sideways. If your wire cutters are not sharp enough to make a nice sideways cut, I would suggest getting new wire cutters either before you continue or after this. These wire cutters were like $10 and they've lasted me years. They're not, they're duller than when I got them, but that type of wire cutter is going to do a lot of good work for you. All right. So first thing we're going to do now is we're going to populate our active components, right? These components have a specific direction that they're going in. If you don't put the direction in correctly, if you don't put the component into the board in the right direction, your board will not work at all. Like, it won't do anything. You'll be left with a piece of trash, right? And we don't like turning electronics into trash at Mystic Circuits. So what we're going to do is we're going to double check a couple times that everything is right. All right. So on your LED, you should see the red piece over here, and you'll notice that these legs are different sizes, right? There's a short leg over here and a long leg over here, right? So the short leg is what's called the cathode. And the cathode always needs to go towards a more negative voltage in order to pass a voltage. It kind of acts like a little gate where it only allows through positive voltages, right? So as you can see on our board, we either already had that white line over here or we marked it with our Sharpie. We are going to put the cathode into that leftmost hole. A little hard to do because I'm actually sitting somewhat far away. All my filming equipment is in the middle right here. But basically, if you're reading the board, right, the CV is in your upper left corner, and you look at the bottom, you should see the short side of the LED sticking through on the left. All right, that means the cathode is facing that CV jack. Okay, if you are at all unsure about this, pause, double check, go back and rewind, make sure that that LED is facing the right direction. If you don't do this, your board will not work. All right, so check however many times you need in order to make sure that this LED in this hole has its short leg facing the left of your board towards the CV jack. And then once you are 100% certain that that is the case, we're going to do the same thing that we did with the resistors. We're going to hold the LED in place with our finger and then send the legs in opposite directions to help keep it still. Are you sure that you did it right? Because if not, I'm not sending you another kit. All right. Now we're looking at the Vactrol. So you might have a different looking Vactrol than this. I've populated these boards with maybe like 3 or 4 different companies, but we've settled on these MEMS ones because the failure rate is quite low. All right. So you'll see, can I zoom in anymore? Okay, so you should see the logo, and there's a little positive and a negative thing right here. A Vactrol is literally just an LED, which is that part that you just put in your board the correct way. It's an LED in a plastic package with a light sensitive resistor, right? And the light sensitive resistor is usually the part of the equation that's a pain in the ass. A lot of Vactrols do not work very well because of the light sensitive resistor. There are a lot of manufacturing. You know what? You don't need to know any of this. Basically, light sensitive resistor and an LED. The LED is able to be lit up by a voltage going through it, and then that controls the amount of resistance in the light sensitive resistor. So if you're looking at the MEMS package or at the other Vactrol you have, the other Vactrols that I've put in all have a little white dot down here, which is on the side of the LED where they have the shortest leg, right? Being the cathode again. The MEMS has this fancy plus and minus. I personally feel like they might have just wanted to mark the minus. That's usually the most important part, but you know what? They know what they're doing. So on any of the Vactrols that you're using, this short leg should be the one that indicates the direction of the Vactrol. Either look for the shortest leg. You'll see on this side the legs are both the same length, and they also kind of go out at like bunny ear angles, right? Like that in different directions. On this side, they're parallel. They're perfectly parallel, and one of the legs is shorter. All right. So what we're going to do is we're going to ensure that the short leg of the Vactrol is facing this corner, the short leg or the dot on your Vactrol, right? It's either a pink or a white dot. It's facing this corner, right? And you can actually see the LED symbol inside the Vactrol facing down. That's where the cathode goes, right? So our cathode, short leg, or dot is going to be facing the mix-in jack, all right? And that is the Vactrol square where we put the Vactrol. That's the corner that has the slanted side. And that's partially because that footprint was made after the VTL series Vactrols, and they have a slanted size. I don't remember. I try not to buy Vactrols. In fact, I'm not a huge fan of this 0HP. Once these Vactrols are gone, I'm probably not selling it anymore. But what we're going to do is we're going to take the entire thing. You want the MEMS logo, or, you know, just make sure that the orientation is correct, right? This is sort of where it's going to go. And what we're going to do is we're going to bend the legs down so that they're able to go into the board, right? These, the bunny ear side with the light sensitive resistor is longer. So we're going to put those in first to these two holes that are wider apart, right? Because the bunny ears, they have the angle to do that. And then we're going to take these other two from the LED side, make sure that they're going in. We're making sure that it's all going in the right direction. And then we press this all down. And this is a good time to re-verify that everything looks right before you bend the legs around, just because it's a sort of a pain once the legs are already bent, right? So we can see here, if you have this Vactrol and you're able to read it, like it's not upside down like this, compared to the rest of the text on your board, you're in a good you're at a good starting point, right? So we're going to go ahead, flip this upside down, and then make sure that the short leg right here is facing our mix-in jack. Just again, if you're at all unsure, pause the video, go back. If you mess this up, it won't work. Right? So once you're absolutely sure that's what you're doing, usually what I do is I send these bunny ears kind of like this direction. Actually, no, let's do it like this. We're going to sort of do them across from each other. It's like a swimmer almost, right? So the bunny ears are going in that direction, and then the LED legs can go in this direction, right? So now everything can sort of be gotten to. You might have to bend some of the legs around, but I'll show you what to do. So once we're sure everything is looking good, I'm going to start by soldering in these LEDs, right? And so we're going to go ahead and tin our tip again. I'm doing this off camera because I don't feel like zooming out and refocusing. We're going to do the same thing as earlier. We put the iron next to the leg, place in the solder until we see a little Hershey's Kiss shape form on the joint that we're trying to do. And you can see here, I just put the solder on, but you can see a little bit of the hole still where the pad is. I'm going to go ahead and put some more solder on there because that doesn't look like a good joint to me. Right. Much better. You can see now the hole is gone. All right. So wait a second or two before doing this. Bend these up. It'll make it easier to get at these legs, which I'm going to do now. Right. Wait another second or two and then bend these up. And then we're going to hit this LED. I can tell already that that joint I just made is not good because the leg is still, you see how there's that ball of solder on top? And when I move the leg, the ball of solder moves as if there's nothing there holding it still. That's a bad joint. That's a cold joint. And you can see the hole too, right? It's good sometimes to be able to show what doing it wrong looks like, right? So I'm going to go back, heat things up again. Just going to heat this up just because I feel like there's more solder than there needs to be on there, all right? And now in comparison, you can see when I move this around, it looks like there's something in the actual joint that wants to stay still. Wow, I did a couple cool joints on this one. Just goes to show, even if you've been soldering for 15 years, don't automatically trust that you did things right. You got to go back and check by eye. Sometimes a cold joint like that can cause something way more complicated than this not to work, and then you'll spend hours tracking down the issue. All right, so now that we have tested all of these joints, go ahead and take my wire cutters, cut them off. Again, being careful not to apply any vertical force to the joint as I'm cutting it. I want to make sure that all of these joints stay intact, all the traces due to. See a couple places that have a little bit of extra wire. I'm going to take off. Okay. So here's what you should have so far. Here's the other side of the board. Everything's looking good. Now what we're going to do is we have two parts left, right? And this is where you are going to make your decision as to whether or not you want a low-pass gate or a VCA. The low-pass gate will filter the circuit, the audio going through it, as well as dampening and attenuating it. So you get the kind of filter swooshes. This is the kind of classic Buchla bongo. I kind of hate that term, but like the Buchla bongo sound comes from using a low-pass gate with a Vactrol. A VCA will not color your audio going through it at all, so you'll still get the plucky percussive feel of a Vactrol, the automatic shaping of the control voltage that will turn a trigger into an envelope, but it won't give you the characteristic filter sweep and reduction of higher frequencies that are going through it as the filter is closing, right? So if you want a cleaner signal, a Vactrol VCA is probably one of the cleanest VCAs you can make that does not color your sound at all. If you want a little bit more character and coloration, or if you're just unsure about it, I would suggest going with the LPG. So we're going to do the LPG today. Go ahead and take this capacitor, and I'll actually show you like what it looks like to populate both parts, right? So this little capsule that's like the only footprint left. It has a bunch of illegible text around it. Is where the capacitor goes, right? This resistor got bent in a really weird way, but it doesn't seem to be causing any problems. And the VCA resistor, if we do this, you do it into the U-turn shape just like the other ones. And the VCA, you can put the body on either side. Neither of these components are directional, but you would put a VCA in here, or a resistor in here for the VCA. Like I said before, we're going to do the capacitor. So go ahead, put the capacitor in this open footprint. We're holding it with our finger, bringing the legs on both sides, and then soldering. Again, good idea to tin your iron just because it's been sitting there for a second. I tin my iron every single time I am about to start soldering on the first joint. And quite frequently, we'll do it several times. I basically tin my iron every time it feels like a joint doesn't want to be soldered, right? And you get a sense for these things. You know, you can speak to the solder, all right? So those appear to be good joints. I'm going to go ahead and cut off the legs. We're almost done with this thing, right? So this is what it should look like, except that there would be a resistor in there if you chose to do the VCA. Now we're going to go ahead and put in these jacks. The jacks have 3 pins. You'll notice there are 3 holes for every square where the jack goes. The part of the jack where your cable comes in is always facing the outside of the board. And with these jacks, we want to make sure, to the best of our ability, that they're all as flat against the board as possible, right? Because it's a pain in the butt to put on the case if they aren't, right? So you might see a jack like this where you're able to see underneath. Just take your finger, press down against it. You can even take the entire board and kind of like use your monkey strength to push everything down as flat as possible. But yeah, once that's the case, you might have to raise the big ball of solder. You might have to raise the heat on your iron a little bit for this because these larger tabs require more heat. But basically, we're going to place the iron against the side, press the solder in until that entire hole has been filled. Almost done here. All right. So technically, you don't have to solder any of these sideways lugs. These 4 that are facing the other direction, because we don't use any normalization connections here. But if you're at all unsure, you know, if you've never soldered anything before, I would suggest just doing them so that you know you haven't mixed anything up. Right? For me, it's like if I'm soldering 20 of these things, I try to avoid any unnecessary soldering that I can. But if you're just doing this, you know, just this 1 or maybe 2 or 3 kits, never hurts to get a little bit of extra practice in. All right. So we can see, just looking at this, that all of these joints seem good. There's the little Hershey's Kiss shape that's kind of stretched sideways by the sideways pins of the jacks. and we can't see any of the holes anymore. All of these holes are all filled with solder. So what I suggest cutting these 6 pins, because due to a design error, they sometimes short against the bottom of our case in a very silly way that it's possible I've fixed before you got this kit, but it's possible it hasn't. So just do it just in case, right? So now you can see the middle of our board doesn't have anything sticking up. This is what your board should look like, right? Okay, we're all done soldering. So now what I'm going to do is I'm going to take our case, right? You can see here we have the lid. It's either our voltage controlled amplifier or our low pass gate. Because we did the low pass gate, I'm going to use this side. We're going to start with the 2 short sides in order to assemble this case, right? So if you kind of put your case lid up here and compare it to these short sides, you can see there's a little tab at the top. That tab goes through either this hole or that hole, and I'll move my hand out of the way so you can see there's these holes in each corner. Each corner takes a tab. So I'm going to go ahead and you'll notice that the jacks are further to one side. Those go towards the top of the case. I'm going to go ahead and do it like, actually, you know what? I'm going to do it the same way that I did it on the other cases. Just align the tabs with the holes. Put the tabs through the case. All right. Press down. Make sure everything looks good. You should see these 2 tabs occupied. You shouldn't have had to fight too hard to do this. If you did try flipping one of these sides over, it's possible that you have it upside down. This is what you should be looking at, right? So now we're going to go ahead and take the long sides. I usually like to make sure that the logo is facing towards the lid instead of the bottom. You kind of place it in. It'll fit with the other pieces like a puzzle piece. You might have to hold it still depending on how loosey-goosey all of your parts are. Right? So now this should be what you're seeing. And if we place the lid upside down, we have the bottom here. You need to match the slots on the bottom with the tabs on the sides. So I have to flip this over, right? They're oriented in different ways in order to accommodate different modules. And what I did there is I stuck 2 of the tabs on the same side in at once, and then you might have to kind of wiggle the rest of your sides around until all of them are in place, right? And you should feel a sort of telltale snap when all of it comes together. All of the forces are, you should be able to put it on the table and it stays mostly still. And at this point, we're going to put in our case hardware. So I have a bolt. You put the bolt through the front. You should be able to push it through. If not, it sometimes helps to take your screwdriver and kind of screw it through the problem areas. Then you can take your rubber foot, you put it there. There should be a little cavity in the rubber foot where your nut goes. All right. And before we flip it over, I'm going to put my finger over that cavity to hold the nut in place and then tighten the screw. If you don't feel the nut mating with the screw threading, you can push towards the side, sort of like I'm pushing down here. And that will help the nut make contact with the threading. Now I'm doing the opposite corner, same exact thing. And I forgot to mention this, but you're going to want to make sure that your case labels are matching the labels on your circuit board, because if you put this case on upside down, everything is not going to match. You're going to think your board is busted. So if you build this and it doesn't work, go ahead and take off the case and make sure that the case is going in the right direction, right? And you should be able to tell once you put a voltage into the CV, this will light up, all right? So Doing some of this. Sometimes if I feel like the nut is just rotating in the little cavity, I'll kind of unscrew and then screw it back in. Sometimes the nut will be at a slight angle, and that makes it so that it won't tighten completely. You'll just have to figure it out. You're smart enough to use a screwdriver, right? Okay. That's our finished case with a finished module inside. So, that should be everything. If you stick around, I'll show you how to test and make sure that your module is working correctly. And yeah, thanks for watching. All right, so now that we've built our low-pass gate and or Vactrol VCA, we'll go ahead and set up a little patch to test it. I'm going to go ahead and take a trigger. I'm using the boundary because I'm able to sort of change the pulse width of that trigger really easily. Plug in, you should see this light start to light up. And then we'll go ahead and plug in an audio source. In this case, I have a sawtooth coming from the 3-body, and we're able to hear the signal being turned on and off. You can kind of either make the triggers faster or make the fall time shorter or longer. Your low pass gate is probably going to sound different than this one. This one is really fast. Yours might ring out a little bit longer. And then another thing you can test is either with the same audio you can plug into the mix, or you can take your patch here and plug another signal into the mix just to make sure that it mixes together correctly. But yeah, that should be a working low pass gate for you. Hopefully your build was successful and fun and informative, and you're having a great day. Thanks for watching.